So, hello everyone. I'm Mario. I'm a Google developer expert for cloud. And as Yevgen already mentioned, I also organize the Google Cloud Munich, Google Developer Group Munich for cloud together with Yevgen. And usually we would meet up like every other month, but as you can imagine, it's kind of hard to meet up in person right now. So hopefully in the end of the year, we will have some more in-person events. You can find me on Twitter under this Fahlandt handle. So if anyone wants me to follow me, there you can find me or ask questions or whatever. But to get straight away, this was all of the presentation because, as Yevgen mentioned, we are doing everything live. So I prayed to the demo gods in the morning that they will not be as bad as anyone hopes to be. So let's go into the Cloud Shell. The cool thing is everything that we do today, you don't need an editor for this. You don't need any previous knowledge in GCP for this. So the only thing you need is basically a Google Cloud account. And you can get a Google Cloud account basically for free, at least for a trial period. And all that I'm showing you today, you can probably also do with the always free tier in GCP, which is pretty neat. So how do I get here? So when I log into Google Cloud, you have like the Google Cloud Platform webpage, and there you have your interface. And when you go on this small icon there, you can activate the Cloud Shell. And when you activate the Cloud Shell, you end up getting to find the right window in this beautiful view, which is pretty neat because you have there a small VM, and inside of this VM, you can develop everything, and you have like an inline editor, which is also pretty cool. So there you can just create everything and have it inside a running VM. And now you would say, but how do I get my code into a repository? This is also brought to you by GCP, and it's included in there. You have the source repositories. In source repositories, it's basically like GitHub or Bitbucket. You have just a Git repository that you can use for your source code. So when we open the Git repository, I already created one. And there we have like one file that was put in there. You can there easily clone the file. So just insert an SSH key. Or if you create a new one, it also tells you what to do. So inside of the Cloud Shell, it's just a couple of commands that you can use to actually, open it. And I already missed it again. So basically what we can do here is, so that everyone can read it, you can just say gcloud, which is the command shell for Google Cloud that you can also download to your local PC. You can say gcloud source repository clone and then give it the name, and then just say in which project it is. So this is pretty amazing because you don't need to use like git commands and stuff like this to clone it. And then you have your source repository on your machine. So what else do we need? As we want to run it in GKE, so the Kubernetes cluster of Google, the easiest way to do this is we first need a cluster. So we go here. When you open this menu, you find a bunch of pinned things. But what we are looking for is Kubernetes Engine. If you want to have it in a quick access on the top, the easiest way is just to press this little pin thingy to put it onto the top. So, and now we want to go to clusters. And there we can now create a new cluster. And for this cluster, when it's loaded, we can give it a name. And there's also the possibility to just use it in a really quick start way, or you can go deep into it to configure what configuration you want or you need in the GCP to run the Kubernetes cluster. So we will just do a couple of settings here. So first, the name of the cluster is now Dachfest. And then we need to say where it should be placed. So we can place it either in a region or in a zone. What's the difference there? Each region consists of different zones. So basically, if you want to have a highly availability cluster, you would put it into a region, because then you have replicas in each of the zones. So when you have replicas in each of the zones, if one zone goes down for whatever reason, like power outage or something like this, the other zones will take over. If you place it zonal, you have the issue that only one zone is available, and only one zone is having if there's an outage, you can't access it there. So, but we go for a zonal approach for the demo now. So we say we want to have it in Europe, and we want to have it probably in Germany, and Germany is Europe West 3, and we use zone B. Then you can say which version you want to have for Kubernetes. So you can have like a standard version or the newer versions. We go with the standard configuration for now. And now it comes to the nodes. So how many machines we want to have, and how big shall they be, and so on. So what we're doing now is we now say, I want 3 nodes, which is fine. We can put the nodes here again into a special zone, but for now we just leave them there where they are, and we can automatically scale them. So if there are no resources left in this zone, we can scale them up so that they scale up automatically. So, and we can enable automatic repair, automatic upgrade, and so on. So, and now when we have a look at the nodes, we can now define how the nodes of the cluster will consist. So we can say, okay, I want to have like the machine type for that we want to use, like if it's more computing heavy or if it's more memory heavy. So you have different options. Be aware, the prices for this are varying, so always check out the price side depending on what you're using. So what we are using now is, because we only deploy a small Node.js application, so the smallest one is fine. So we use an E2 micro instance. They changed the name, like in the past they had other names, but for now we just use, we have 2 CPUs and 1 gig of memory. Also, we can say how many default storage it shall be, and we can add network tags, and we can add security accesses, and we can add metadata. We can automate things, but for now, for just getting started, we just go, please create this cluster. So this now takes some time. You see there we have now a new cluster, and it's now generated. So in this time, while this cluster is generated, we start with our small application. So, and to start this application, we go back to our Cloud Shell, and forever everything in Kubernetes is is defined by YML files. So we define in the YML file that we have like an application that is running, which is inside of a deployment, because we deploy it multiple times, or we can deploy it multiple times. And we also need a service to expose it to the public. So what we are doing now is we create a new file and we name it deployment.yml. All right. So, and the cool thing in this Cloud Shell editor is you have autocomplete and you have everything that you need for coding inside of your editor. So, and what we want to do now? So we want to do now a service, and we just use a specific AP version, which is in this case v1. And to define the service, we have now metadata, and we need to give it a name. So we give it the name server. Server is a cool name, and it gets the labels app, and we call it also server, because I'm literally not that great in naming things. So this is now, we have now a definition for this is a service. So this is the task of the service is to manage all of the replicas that we have, so that the traffic comes from one point and gets redirected to all of the services. So what we are doing, what we need to do now is we want to say where does it point to, what kind it is, and which ports shall be open. So we say we need a selector, and the selector is again server. And then we need to define which ports it should point where. So we can now say port 80. So everything that comes from HTTP, from the internet, shall go to with the protocol TCP, shall go to our target port. This is where our application is running onto inside of our Docker container, 8080. And our type, what we are using here is a load balancer. So it balances, so it basically checks which port has capacity free and then routes it to this point. And that's it. This is the complete definition for load balancing your first application. And the next thing that we can do now is we now need a deployment. So we now need to define, I want this application with this objects onto this machine. So onto this Kubernetes installation, and we can now put in there, we need the version 1, and we now want to have deployment. It also needs some metadata, as we now know. I'm a friend of naming everything the same, which sticks together. So it also gets the name server. It also gets the labels for server, and it got a specific spec. And as you can see, it helps me writing all these things, because you have like all of the autocomplete, and it highlights you when you have made some errors, or there's something not working or not valid. So this helps you already. Usually you also find add-ons for writing YML in all of the various editors. And there's also for VS Code and for IntelliJ, there's the Google Cloud plugin that you can install. So this also verifies if everything is written correctly for Kubernetes, because there you have like the autocomplete for your environments. So, but we and now the important thing for these labels, what we defined, comes up, because now we tell him where it should match, so that service matches to deployment, basically. Sorry if it's weird if I always look up, because on top of me there's another monitor, and I usually check the images there if everything is okay. So we now need to match a specific label, and the specific label was for is for app, and it is as we called it, server. All right, and now we need a template. So the template tells us also the labels again, which is server. And the template tells us the spec of our container. So we will give it the name, server, and it tells you there define what is the spec of the container we're using. So it also needs an image. But we don't have an image yet. So we just say, oh, it's a placeholder. This is fine. And we need to tell him on which port it's running. And as we know, we want, because we use the target port on 8080, it tells us now, okay, I want to reuse, the containers are running and exposing port 8080. And the cool thing is, as you can see here, you have like, not only the autocomplete, but you have also like an inside documentation that tells you what is the thing that you just wrote and where you can find everything. And so that's, yeah, basically it helps you just to write all these things. And now we have our container ready, which is pretty neat. Our deployment ready. And now we need a container. So we need to get our container up and running. For this, I prepared a Docker file. New file. Docker file. And because I'm lazy, I'm just pasting it in. So this is a standard, a small Docker container that is just doing npm. It's using Node.js. It's doing an npm install, and it is starting the application. And we shall expose it on the correct port. So this is better now. All right, and now we need some kind of application. I already prepared something of this. So we need a new file, and we need an app.js. And inside of the app.js, we just have an Express server. And also we need a package JSON. The good thing is everything that I put that I show you here, I already put into in a GitHub repository, so every one of you can just grab it and test it on their own if you like to. So new folder, and we want to call it binary, and there we want to start our server. And now we just need some 1, 2, 3, 4 more files, and everything is fine. This is the problem with demos. When you do them remotely, you need to create everything again. I mean, I could just check everything out, but this wouldn't help you at all. So user controller.js. It's just, yeah, it's just telling us, oh, this is the wrong one. My bad. This one. So we have like just separate endpoints that getting us some student records so that we can basically call specific routes in the end. And as we know, everyone in the world needs tests because we all do test-driven development, right? We also need a folder for tests. So we create a test folder and we put in a new file in there, which is called test.js. And so we have like some tests that are running, because what our goal is, we also want to test things in our build process so that we can have a full CI/CD pipeline, because nothing should go into the internet untested, right? And now we need also a new folder for like our front ends, and we can there create 3 new files, which is error.pack and index.pack and layout.pack. So we just put in some layout there so that we have like a base page. And we can open everything. And now we only need now the routes. So we say routes, and we have like index.js for our routing, and we have like users.js. So this is just an easy router that basically renders us our index page, and we have a router for our REST endpoints. All right, so everything is now in place, except one thing. So we have now our deployment file for Kubernetes. We have our simple Docker file. We have all of our JavaScript files that we need. We have a package.json to basically install the dependencies for our app. But we need something more. And this is now the point where we get to the Cloud Builder. So if we go to the Cloud Builder, you can find it down below at under Tools. You have the Cloud Build. And also we see now our clusters up and running. And in Cloud Build, when we go here, we have a dashboard. And in this dashboard, you see all of your builds. But what we want is, we want a new trigger. So we want every time someone commits something into the master branch, we want to have our system built and deployed. So we now need to create a new trigger. And we call it Dachfest. Dachfest application. And it should always trigger when I push to a specific branch onto my repository. If you use GitHub, because you're not limited to use Cloud Repository, you can also use Bitbucket and GitHub as well. You can even build it as soon as a pull request is created. So basically, you can use Cloud Build to deploy it to your Kubernetes cluster for testing purpose if everything is all right with the pull request. So we can now select in our in source, we can now select out of our cloud repositories our repository. You can also say, I want to add a new repository, and then it tells you want either to use Bitbucket or GitHub, and then you will just have to give access to GitHub or Bitbucket. So, but we don't want to do this because we already have it. So we just say we want to use Dachfest 2021, and we want to build it the master branch. And then it tells us, you have two possibilities. The first possibility is you can build it from a Docker file. The problem with building it from the Docker file is you just build a Docker image, but we want to do some things more. So we don't only want to build a Docker image, we also want to build the image, first test the application, deploy the application, and then in the end deploy the application. And as we haven't created any services yet, it should also create the service. So what we do now is we want to recreate now this cloud build YML file. So it tells us, okay, there's a configuration file we can use, and to create this file, we just put it into our repository as well. So we say new file, paste the name in there, and say, yeah, I want a cloud build YML. So what do we do in there? Basically, this is also a YAML file that you can say, okay, I want to do it in steps. And the good thing is, if you now do it in the Cloud Shell editor, it has also the autocomplete to tell you what is available and what not. So we have different steps. So we can now say the first step we want to use is we want to use from our from Google, from the cloud builders. We want to use npm. So we can now say okay, please do install. What it does is it basically runs an npm install. And then we want to do an gcr.io/ the next time I will copy it. It's way faster than me. We want to do an run test. So we can say run test. So this runs now npm test for us, which is pretty neat. And because I am really, really lazy, I will, and to speed things up because no one wants to watch me typing, we can now say I want to be, if this is running fine, copy paste is always a bad thing. we want to do a Docker build. So what we are doing now is we are now running Docker build, and we can give it, I think I hope everyone hears me. And we can now do an Docker build, so we can give it variables. So as you can see, there are fixed variables like project ID or repo name. We come to this in a sec. And then we just run a Docker build. And for the next thing, we want to push it to our Docker registry. The good thing is here we have a built-in Docker registry inside of GCP, so we can just use this one as a Docker as our Docker registry. And afterwards, we need to apply the deployment file to our cluster. So if you're interacting with Kubernetes, you always are using the kube control shell, as a kubectl, and you can run this either in your shell. So I can here run a kube control, or, which is pretty neat, we can just run it inside of our deployment file. So what we're doing now is we say we want to apply the file deployment YML that we have in our repository. We come in a second to these things because they are relevant. But you can see the difference. These ones here start with a Lodash. This is something to keep in mind. And afterwards, to change the image which is missing in our deployment YML, as you can remember, because we said we don't have any clue where the image is, so we can't use it yet. We can now, as a last step, say we want to set the image of our deployment that we put into our Kubernetes cluster. So we have created everything, and now we can create our trigger for this. So as you can see here, we have variables. Maybe I can switch it to English. Give me a second. Lang en. No, doesn't work. This is still an error, still a bug that you can't switch to English when your account is German. So you have like the substitution variables. So which means you can there put in custom variables that are put into your cluster. So what we are doing here now is we have now the possibility to give own variables, and we need 3 of them. As you can see, your custom variables need to start with a Lodash. So this is what we did here. So we have here like deployment. And we give the deployment the name server. Why do we give the deployment the name server? Because we called the application in our the deployment. In our we gave it the name server. So we just say this is our this is the name of our deployment. I mean, you can hard code it inside of the file, but in this way the file is more usable, which is pretty neat. We don't need the project ID because the project ID is always substituted in the cloud build, or as well as for the repo name and as for the build ID. So we always are sure that this is the project ID where our project is running inside of GCP, and it always is the repo name and how we named our repo. And the build ID is generated for each build. So we know each build generates a next unique ID, which is pretty amazing. The only thing that we now need to do is we need to tell it where is our cluster. So we give it we set the name to the cluster zone, and the cluster zone is easy to find because this is the zone we gave it. It was in Europe West 3B, or where we put it. And what else do we need? We need a cluster name. Of course, it needs a cluster. Where does it go to? So the cool thing is that we can, if you have like, with this file, and if you have like multiple clusters, like one for staging, one for production, one for testing, so development, you can just copy everything. The file stays the same, and you can just define inside of the build triggers where to go. So you have a multi environment deployment as well, which is amazing. So the last name is cluster name, and I think we called it Dachfest. Yes, we did. Dachfest. All right, and that's it. I reloaded it. My bad. I'm stupid. Dachfest. All right, and now we go. You can now jump directly into it, and now we say we need to go into the. I hope it's big enough. I'll make it a little bit bigger, that it's better to read. So we go to Dachfest 2021, and here we have all our files, and we have some new files. So we say git add something you should never do, but everything is fine now. So git commit -m, and we want to give it the name in no time this is running on GCP, and we push it. And now that we push it, yes please, to our repository, we have now all of the code inside of our repository, as you can see, which is pretty neat. Sorry for this. So we have now everything there, and if we go to our dashboard, we have a new build running, and it failed. I upset the demo gods. I knew it. All right. What did I do wrong? So, which is pretty neat. Now you now see all of the build steps that we defined in the file. So we have now our npm install. We run our tests. So we have like the test that we usually run locally, run inside of the Cloud Shell, and it's passing. And yeah, and then I did something really, really stupid as naming the, the repository in capital letters. Yeah, my bad. So let's quickly try to fix this. I hope my time is running out. So this was when you upset the demo gods. So we want a new repository. We want to call it Dachfest and give it into this project, please. Thanks. And we want to This is the easiest way. So you see here that you can easily just copy the commands to initialize everything. So maybe it's easy so that we can say, yes, please. I want to use this account. Thank you very much. And I was to use this project. And no, I don't want to configure any zones now. And now we can say, hopefully we can this just works for us. So we can say this. Demo gods. I upset them. Maybe this is working. Maybe this is working. Let's have a quick look. So we go to not this one, but all repositories. Come on, come on. Lowercase Dachfest is working. Yeah, we have the files in there. So we go back to our Cloud Builder and we want to go to our triggers. And we want to change this to something that is not bullshit. And no, I need to copy the trigger. This is sad. Okay, new trigger. We want to use the Dachfest, which is chemicals. This is Dachfest. Correct. And we quickly need to put in the variables, which is deployment, which is server, and and then we need to push in everything which is in here. Cluster zone. And cluster name. And cluster name was Dachfest. And your rest 3B. And now we go. And the good thing is it already is pushed. So you can always say, run the trigger. And you can also then change the variables, which is a new feature that came out not so long ago. So if we go now into our triggers and we see now our build, we can actually watch it, what it currently is doing. So the test passed. So we are basically now at this step. And you can now see it's now pulling the image and it's building the image. Come on. And now it's still building the image. It's tagging the image now, as you can see. Oh, no, probably you can't see because it's way too small. It's tagging the image. And we now have this image tagged. So if we go parallel into our container registry, which you also can find under tools, the container registry. This is what I told you. So we have like the container registry, and inside of the container registry, you can now find the image that we have just created. So you can always download your images from there, which is pretty amazing. And while this is doing, we have now pushed everything to our registry, as we saw. We also have now the servers created and the server created. And there we have an error because I probably mixed something up. But what we can do before we check for the error, if we have a look here, no, I don't want to have this information. We can now look into our cluster. And I don't want things. So when we now have a look in our cluster, we already can see that in Dachfest, we have now a new deployment, which is called server, which is obviously not running because the last step was not running, because he couldn't find the image. But what we also have is we have the server created in our Dachfest cluster, which is now a load balancer with an IP address that we can actually open in the browser, which would show nothing because the image is not there. So let us quickly check what the demo gods did wrong there. And deployment, probably I just didn't write the thing correctly. So if we go to our cloud, in our details, we can now have a look at the triggers again. And we have a look there. This is right. This is right. Because the error that told us was this was wrong. So let's quickly check the code again. So we have our deployment. It's called server. The app is server. The labels are server. And the containers are server. And what was the error that was told us? Let's have a look. Yeah, it didn't set the environment variable for deployment. I guess I just named everything wrong. So we have a look again at triggers. And we have a look at, no, I looked in the wrong one. My bad. We have a look at there. And deployment, yeah, and server T. Deployment and server T is definitely the wrong variable. So if we have the right name, am I in the right? So this looks better now. So we can go back here, build again, and no, the wrong one. No, this is the right one. And we go. And when this is running, and when this is run through, it should deploy our application to our server. But this is now only waiting time. So what basically do you need? You need only a browser. You need some kind of application. In my case, it was a Node.js application, but there are a lot of things that you can already use in there. So for example, if you write Go, you can use Go to run it inside of the cloud build. You can even define the size of the building machines, but only with the small building machines you can you have it in the free tier, because you have, like, I think it is 60 minutes every day for free building time, so where you don't pay anything, which is pretty cool. And I mean, you see how fast the builds go. I mean, even the bigger the image, the bigger the builds will go. But overall, this is basically everything that you need. Also, you can have a look at the resources that will get used or that are available inside of the Cloud Builder. So if you go to this website, you see all of the builder libraries that you can use inside of Cloud Build. So you see, you can also do a Git checkout. You have Go, you have Java, you have kubectl, you have Maven, you have NPM, you have a bunch of things, and you can also use your own libraries to build inside of this machine. So what you can also try is, I think that Docker is also available. So basically what you can do is you can set up inside of this machine a Docker container for like a database to run your tests against this database. And as we saw now, our build was completed, and it set the image. And when we have a look at our repository here, we now should see a new image. And when we look at our server now, we have now a cluster that is running. And we have now our container that is running. And we can have a look in the logs of the container. So we see right in what's going inside of the container. I don't care. So you can now look into the logs in what is inside of your container, but there's nothing that is basically now logging. So, and if everything was right, sorry for this, Kubernetes Engine, we want our ingresses. Maybe if my application was good, we can see something. No. But it's creating. Oh, yeah, because we now have two deployments as I create. No, it's still creating the containers. Okay. So probably I destroyed my. Okay, the container crashed. So remove this, please. And I think okay, we destroyed our image, and he's now trying to recreate it, everything. So this would take some more time, but the deployment process itself just run through. I probably just had an error in the application itself. But this is an easy way how you get all up and running in GCP. If you have any questions, I'm happy to answer them.